Alrighty, so I'm going to work the example problem for you that falls on the 12.4.31 on the example problem that goes with that measures of dispersion assignment. And it's given you the two stores, and in the context of the situation, I believe for 25 days, they counted the number of oil changes that each store did. And they're asking you to fill in the frequency table here. They've given you the intervals to use, so you don't have to come up with that part. So you just need to figure out how many days fall into each of those intervals. So, for example, I'm going to do the East store first. So here we need to figure out the number of days that did 15 to 19 oil changes. And if I look through this table of numbers, I only have one day that they did. So they did 16 oil changes that day. And 16 is the only number in that table that falls within 15 to 19. So I'm simply going to write a 1. Now, what people have a tendency to do wrong on this is that they see that 14 right there, and they think they should include it in that interval because this is the smallest interval, right? So 14 must belong there. But 14 doesn't fall between 15 and 19. So because of that, it doesn't belong. So they didn't give you an interval where 15 fits, so you're not going to put it in this frequency distribution. What I like to do when I've got a lot of numbers like this is as I use the numbers, I will kind of mark them out to make it a little bit easier for me as well. So then I would go to the next category, the next interval. So how many days fall between 20 and 24? So I'll literally just go through here and I will find the number of each day that falls in between or within 20 to 24's interval. And if I'm looking, yep, it's just those 4. So I'm going to write a 4 for that frequency. So I am going to go ahead and finish out the table. What I think would be a good idea for you to do is to pause the video, try to fill it in yourself to make sure that you do it correctly, and I'll be right back. Okay, so I've gone through, I have finished filling out the frequency distribution here. The only thing I want to make sure that I point out to you is that notice here, I didn't have any numbers in the East or any numbers in the East store that fell within the interval of 55 to 59. So you do have to put a 0 there. You don't just leave it blank. You do write a 0 because that particular interval did not pop up, right? So now with number 2 here, or with the West store, what might be a good idea is for you to go ahead and pause the video again and you try to fill in the number of days for the West store. And then restart the video in a moment and check yourself to see whether or not you did it correctly. Okay, so here we have it. Here's my frequency distribution for the West store. Only thing I really want to point out to you is notice here, all of these intervals have no days that fall within them because the highest number from this table, let's see, what is the highest number? I think the biggest number we got up here is 51, which is not big enough to fall into 55 and above. So we do need to write zeros in that frequency table to represent that. So hopefully you managed to do that one correctly. But this completes part A for the question. We made a frequency distribution for both the East store and the West store. So then part B of this question asks you it gives you multiple choice where it gives you several different histograms and asks you to match up the correct histogram with the distribution. And so right here I've got my answer that I had for the East store that I did a moment ago. And I'm just going to show you how you match up the correct frequency or the correct histogram with the frequency table. So you notice, I'm going to zoom in here for a moment, that these are all going up by how the intervals are labeled. So for example, you see that the 20 is right here on the left side of this box. So that means that this bar coincides with the interval that is 20 to 24. And then because, get this stuff off the screen here, because this bar is to the left, it coincides with the 15 to 19. So this one is our 15 to 19. Again, we can tell because it's to the left of the 20. And if I zoom in here, we see that this bar is 1 unit high. So it corresponds with the frequency of 1 unit. The next bar over, of course, representing this 20 through 24, you'll see that it is 4 high. So that corresponds with the fact that there were 4 days that fell into that interval. And I'll do one more just to make my point. So the next bar represents that 25 to 29, and it goes up to 2, which reflects that frequency of 2. So that is there to help you to match up the histogram that goes along with that frequency distribution. You just look for the bars, and the height matches up, like however how high the bar is, that matches up with the frequency in the table. So now here's the histogram that matches the West store frequency diagram. And again, you can see kind of the same thing happening here. So we don't have anything that falls into that first interval of that 15 to 19. So that's why if we zoom in here, there is not a bar over the part of the histogram that would represent 15 to 19. However, our next class of 20 to 24, so this bar right here, does have a height of 1, so that corresponds with the frequency of 1. Then, of course, our next bar does have a height of 3. So that corresponds to our frequency of 3, and so on and so forth. So that is how you determine which histogram matches each of the frequency tables in part B of this question. So now part C asks you to figure out, based on the histogram, comparing the means, whether one appears to be bigger than the other or whether they appear to be the same. So if we look at the shape of the East store, so it's roughly kind of up like this, and I didn't do a very good job of that. Let me try that again. It's roughly like that. This is about the middle, and so you can tell that the middle is roughly right here in that, 40 to 44 interval. And then if we look at the West, the shape right here, again, here's roughly the middle, and that middle also appears to be right here, roughly in this 40 to 44. So both of them have about the same, like the data are grouped around the same middle point. So for part C, I know part C is multiple choice, but you should be picking the option that says that the stores appear to have approximately the same mean, because both histograms are centered around the same point. So yes, the histograms are a different shape. One's wider than the other and shorter. We'll get to that in a second. However, their midpoint, the middle of each of them, is still roughly the same area. So they do have approximately the same mean based on the histogram. Now part D asks you to look at the histograms and to use that to determine whether or not one of them has a bigger standard deviation. So let me get rid of this. And we're going to still keep the little exterior shape there because we do need that. So remember that standard deviation is a measure of spread. It is a measure that helps you determine how spread out the numbers are in that data set. So because East is shorter and the area it takes up is wider, that means that it is more spread out. So if it's more spread out, that means that the East, at least looking at the data here in the histogram, it appears that the East store has a greater standard deviation. So you should select for D, the multiple choice question that corresponds to the idea that the East store has a more spread out shape, which means that it's got a greater standard deviation. So now we used a histogram to estimate whether they appeared to have the same mean. So now part E is asking us to literally calculate the mean and see whether or not our determination from the histogram was correct. Remember, to find the mean of the set of data, you're going to add all the numbers together. So in other words, you're going to find the sum, and then you're going to divide by how many numbers there are in that data set. So in this case, we've got 25 numbers in each data set. So we're going to add them together and we're going to divide by 25. This is where I know it's a big data set. It's kind of a pain in the tail, right? Because it's really easy to make mistakes. So please take your time, double check yourself. Now, when I added all of the numbers in the East store together, I got 925 for my sum, and then I double checked myself to make sure that I did it correctly, which I believe that I did. And then I'm going to divide by 25 because there's 25 numbers in the data set. When I did that, that gave me a mean of 37. Then I did the same thing for the West store. Again, I added all of them together, and then I'm going to divide by 25, and I got it the same sum. I got a sum of 925. Added it, double checked it, did it twice just to make sure, and then I do 925 divided by 25, which means my mean is also 37. So it's a multiple choice question. Again, you should be sure to select the multiple choice question answer, which said that yes, based on finding the mean, the means are both 37 in this case. So yes, those values are consistent with what you got in part C. So you should have something, I know it gives you those little drop-down boxes to pick. So it asks you to find the mean for each store. In that drop-down box, you should have typed in 37, and which means that these values are consistent with your answer in part C. We thought that the histograms made it look like the mean was about the same, and in fact, we proved mathematically that they are. So now part F asks us to calculate the standard deviation for each of the stores. We looked at the histograms, and it looks like the East store is going to have a bigger standard deviation. Again, that was because the histogram was wider, which makes us feel like those scores are probably more spread out. But now we've got to calculate the standard deviation, and I know this is the one that, man, this one is doing a lot. There are a lot of steps for finding the standard deviation, and especially when you've got 25 numbers to do it. The best suggestion I can offer you is please just take your time. Double check your work. Make sure that you're doing it correctly. Okay, so I am going to start off by recalling that my mean, which I calculated in the previous step, was 37. So remember, when you're finding the standard deviation, the first step is to take each number in the data set and subtract the mean so that you can find the difference, basically how spread out is that number from the mean. So the first thing I always do is I literally write myself out like a table with all of the subtraction problems written out. So I'll do 16 minus 37. Now 61 minus 37. 22 minus 37. I write all the problems out. Some of you guys might think that that's a little bit of overkill. You'd prefer to just go ahead and do the subtraction. But I'm going to tell you what, for me, it just makes it easier for me to go step by step to make sure that I don't make a mistake. So it's just a suggestion. Okay, so here is where I have taken all of those numbers. I've written out the subtraction problem. So as you can see, I've taken each number in the data set and I subtracted the mean from it. And so I've got 25 separate differences. Each one of these differences after I did that subtraction problem. Now, of course, we all know that we're not done, right? I now need to take all of those differences and I need to square them. That means that I need to multiply them by themselves. So just for example, of course, to square negative 21, I would do negative 21 times negative 21, and that would give me 441. I would square 24. I would do 24 times 24. That would give me 576. Okay, I'm going to pause the video. I'm going to go ahead and square all these numbers so you can come back and check yourself in just a second. Okay, so now here in the blue are all of the numbers that I got after I squared those differences. And of course, now that we have all of those numbers squared, so all those blue numbers that again I got by multiplying each difference by itself, now we need to add all of those numbers together. And if I did that correctly, I should have gotten as my total, and again that's from adding all of these blue squared numbers together, I should have gotten 4,830. And then now I need to divide. Now, very common mistake that people make is that they divide when they're finding standard deviation by the number of numbers in the data set. I know that's what you do in the mean, but remember standard deviation is different. You don't divide by the number of numbers in the data set, you divide by one less than the numbers in the data set. So instead of dividing by 25, I'm going to divide by 24. So if I do 4,830 and divide by 24, that is going to give me a quotient of 201.25. And I am almost done. Almost. My very last step is that I have to take the square root of that 201.25. So the standard deviation for the East store is approximately, I'm going to round to the hundredths place, 14.19. Because I get 14.186, blah, blah, blah. It goes on and on and on. So I'm going to round it to 14.19. So now, of course, I have to do all of that same stuff with the West store in order to be able to find the standard deviation. And I'm going to do exactly what I did for the East store. I'm going to take each number in the data set, and I'm going to set up a series of subtraction problems. Exactly the way that I did before. Okay, so now here are all of those differences that I found from the West store. Again, I was very careful to double check myself and make sure that I did the subtraction correctly. So all of those green numbers are the differences. When I subtracted every number in the data set from the West store, and I subtracted the mean of 37 from it. So then, of course, my next step was to take all of those green numbers and square them. So in other words, I did 4 times 4, got 16, 14 times 14, got 196, etc., etc. So got all of those blue numbers from squaring the green numbers. Then, of course, my next step is that I need to add all of those blue numbers together. And again, the whole time I'm double checking myself to make sure I don't make any mistakes as I go. Once I did that, I got 1,406 from adding all those blue numbers together. Then, of course, I don't divide by 25, I divide by 24, because you divide by one less than the number of numbers you have in the data set. So 1,406 divided by 24 gives me a little bit of a crazier decimal than I had in my other one. So I'm actually going to replace this equal sign with a squiggly equal sign that means approximately, because it's kind of a crazy decimal. So I'm going to round it to 58.58. I'm going to round it to 2 decimal places. And last but not least, I have to take the square root of that 58.58. So the standard deviation for the West store, again, is approximately, I'm going to write it down here in green, 7.65. So my standard deviation for the East store was over 14, My standard deviation for the west store, actually, because I know we're visual, I don't know why I'm just trying to rattle this off. Let me bring up a blank screen here. Okay, so my standard deviation for the east store was 14.19 approximately, because again, we used some rounding. My standard deviation for the west store was 7.65 approximately. So remember in the previous, I believe it was part D, yeah. In part D, we looked at the shape of the histogram and we saw that the east store was shorter and wider and the west store was taller and less wide. So that implied that the east store standard deviation was going to be greater because the numbers were more spread out, and here we are, we proved that numerically. So for part F, you should have put in the correct standard deviations into the fill-in boxes, and then you should have said that these values are consistent with our answer in part D, because we said that the east histogram was more spread out, so the east standard deviation should have been larger. And as you can see, it's almost twice as much.